In this video, I'll be working through the questions you see on the screen, and this question is from the winter edition of Cambridge International Exams from 2023 from paper 1-2. If you want any other questions from this paper, there should be a link to a playlist in the description below. I do these on a whiteboard, hopefully to mimic how you're used to watching your teacher teach these questions. And if you find any of this useful in any way, please like, subscribe, and even share it with some friend that's doing the exams or someone doing it next year. In question 6, they give us an equation of a curve, specifically y is equal to x squared minus 8x plus 5, and they ask us to find the coordinates of the minimum point on that curve. So this should be a fairly straightforward question. If you see minimum or maximum, you should be thinking derivative, dy dx. So that's a good place to start. Let's find the derivative. Dy dx of this is 2x. Derivative of minus 8x is minus 8. Derivative of 5 is 0. And the derivative at a minimum is equal to 0. So that allows us to solve for x. We can rearrange this. We get 2x is equal to 8. X is equal to 4. Do not stop there. Students stop there, they lose a mark for no reason. They want the coordinates. They wanted both x and y. You still need y. Y is equal to 16 minus 32. I'm just putting 4 in here. 4 squared, 8 times 4, 32. Plus 5, what's that? That's minus 11, I believe. Let's just double check my notes. Yes, minus 11. So that'll get you full marks, but I always like to just put the answer in a bracket like that, in a coordinates. Okay, so that's the answer to part A. In part B, they tell us that the curve is stretched by a factor of 2 parallel to the y-axis. That means going up and down there, being stretched that way. And then it's translated by 4 and 1. And they want us to find the coordinates of the minimum point. Let's draw it out just so we see what we're talking about. Let's put a y-axis, give ourselves plenty of room here, the x-axis. The point 4, 11, let's go 4 and 11, like that. We know the y-intercept was 5, let's put that here somewhere. So the curve looks something like this. Again, it's just rough thing for an example here. So what they're saying is they're stretching this. This point stays the same because it's on the x-axis, doesn't get stretched. But the 5 will get stretched up by a factor of 2 to 10. So this is 5, becomes 10. This down here, this was minus 11. That gets stretched all the way down to minus 22. And it would look something like this. So it goes through there and comes up inside. Looks something like that. We'd have a new minimum at 4. This said 4. At 4 minus 22 would be the new minimum. But then they weren't finished. They also translated it. Translate just means moved it. They moved it 4 to the right and 1 up. 4 to the right and 1 up. So it just became here. Everybody moved 4 to the right and 1 up. I don't know, let's go this guy. 4 to the right and 1 up. Like they all moved. 4 to the right. I guess 4 to the right. Anyway, they all moved. So what is this new point? What's 4 to the right of 4 is 8. 1 up from minus 22 is minus 21. That's the answer to part B. I just used the drawing to help me think it through. But just to say that again, stretching in the y-axis. Let me start this question again even. 4 minus 11. This is the answer from part A. If we stretch in the y-axis, the x-axis isn't changed. So that would just become multiplied by 2. So let's see, stretch, how do I spell stretch? S-T-R-E... TCH, stretch 2 in the y-axis. That's what I did there. Next, translate. Translate by 4, 1. That's 4 in the x and 1 in the y. That's, I'll just say tran by 4, 1. that's what I did there in maths. I just tried to draw a picture to help you think it out. Okay, let me clear this off and we'll do part C. I guess I'll keep this part, yeah, I'll keep the drawing, but really we're going to do the same thing, but instead of to a point, we're going to do it to an entire equation. So as I said, part C, they want us to take this equation and transform it like we did above. We're going to stretch it in the y-axis. So let's start off here and we'll just work our way down here. Start off in the y-axis and we're going to stretch it. So again, I have to spell stretch again. We're going to stretch it times 2 in the y-axis. So what does that do? We'll always have y equals. That's what an equation looks like. Well, I guess I'm going to play around with that a bit. But we're going to stretch the y. So y equals everything over here. So everything over here gets twice as big. 2x squared minus 16x plus 10. That's what stretching it in the y-axis means. And that should be a bit clearer because of this plus 10 here. Because remember, the y-intercept did get stretched up to the plus 10. So that should be clear enough, the stretching one. Next thing we need to do is the translation. So we're going to translate by 4 and then 1. Let's do them both separately. Let's first of all translate by 4 and 0. So just the x translation. So how I remember this is if x was, so I'm not sure what the solving points are here, but at a certain point, there's two numbers I can put in for x that will make 0. And after I move them 4 to the right, those numbers will be 4 bigger that make 0. I hope you're following that. I don't think that was very clear at all. So how I remember it is, it's this x here squared. This x changes, minus 16, and the x in here changes plus 10. How I remember it is, if I translate 4 to the right, you know what, let me draw a new one here. Let's say this hits at 1 and this hits at 6. So if I translate everything to the right by 4, I would get 5 here and 10 over, sorry, by 4, yeah, 10 over here. And I'd get this new function like that. So my old function, when I put 1 in it, I expect a 0 out. The new function, nothing changes except that when I put a 5 in, I want a 0 out. So that my expectation has moved 4. So I have to take 4 away from here. So previously if I put a 1 in, I got 0. Now I still need to put a 1 in this whole bracket to get a 0. But it's been moved, so it's a 5. So it's basically, I have to take away whatever I've put in. I'm really not explaining that well. I hope I sort of got there. I'll think on it, and if I can think of a better way, I'll edit this and say it all over again. But if you're moving it to the right 4, we need to take that away from each of the x's, just to make sure they still come out as 0. At least that's how I'm thinking of it. And you can go ahead and multiply all of these out. We'll still get an x squared. An x squared will appear out of this, and we'll multiply by 2. We'll still get loads of x's. Where will the x's come from? 4x, another 4x, 8x. 8x by 2 is, that's be minus 16x. Another minus 16x. So we're going to have minus 32x. Let's see, where will all the numbers come from? We'll get a plus 16 here, times 2, that's 32. We will get a plus 64 from these two, 16 times 4. Add them together, we get 96, plus 96, oh, and another plus 10. So plus 106. And that was with this translation, 4, 0. Last translation to do would be the 0, 1, the y part of that. And my same logic holds. I'll have to take that 1 away. Whatever I move it, to make this equation still work, I'll have to take that 1 away from the y. Now it's much easier to do for the y. It's 2x squared minus 32x. In fact, often you'll see this row as y equals and just add it on to this side. Plus, just add 1 onto this side. So we get 107. Let me just double check that is my final answer. Yeah. Okay, I don't like how I've explained that. So if you're still seeing this in the video, it means I either ran out of time to fix it or I couldn't think of a better way to explain it. I apologise for that. If you know a better way to explain this, please let me know. I'm not perfect at maths. Always happy to find new ways to do things. But thanks for watching and have a great day.